So in Chapter 9, we are going to be studying conic sections, which are circles, ellipses, parabolas, hyperbolas. Technically, you could consider a line to be a conic section, but it's not very similar to the others. The definitions for all of the conic sections, which, in case you don't know already, are shapes you get when you slice a cone. You get a circle, ellipse, parabola, or hyperbola. All of which you've seen before, those shapes. But their definitions in geometry are all based on distances, and some of them include midpoint, although usually the midpoint isn't what's used in the definition. Usually for midpoints, what we're doing is we're trying to find points on the shape, and for that, finding the midpoint of a segment is helpful. So we're going to take a soft landing into analytical geometry in Chapter 9 by remembering the distance and midpoint formulas, which you should have learned in geometry. They're really very straightforward. So this section, there's almost no guesswork. It's just a matter of using and applying the two formulas. The distance formula is based on the Pythagorean theorem, which, if you can notice how it's related, I'll try to explain it to you. That makes it easier to remember. But it's the square root of the difference between two x values squared plus the difference between the two y values squared. Technically, it doesn't matter whether you do x2 minus x1 or x1 minus x2, because you're going to square it anyway, so it will wind up being the same. But a general rule of thumb for differences is to do final minus initial, so the last one minus the first one is a good go-to default for this sort of thing. So the square root of the square of x2 minus x1 plus the square of y2 minus y1. The midpoint formula finds the midpoint between 2 points. In this case, the 2 points that we're talking about for both of these examples are x1, y1 and x2, y2. In the midpoint formula, the easiest way to remember it is to remember that halfway between any two numbers is the average, the mean of those two numbers. So you take the x's, add them together, and divide how many there are. Well, there are 2. And you do the same thing with the y's. You could remember this as y2 plus y1 if you wanted to keep it similar to this one. The order doesn't matter again because addition is commutative. So to find the distance between 2 points, you subtract the x's, subtract the y's, square them, add them together, and take the square root. To find the midpoint, you average the x's and average the y's, and that gives you your midpoint. The rest is examples, so let's do a few. Find the distance, let's find both the distance and midpoint between negative 5, 1 and negative 3, 2. Understanding that I do not guarantee these are nice ever. So the distance formula says we're going to do the square root of the difference between the x's. Negative 3 minus negative 5 is the same as negative 3 plus 5. Square that. Do the difference between the y's. 2 minus 1 squared. That's positive 2 squared, which is 4. That's positive 1 squared, which is 1. So the answer is the square root of 5, which I'm going to leave like that. If you really want a decimal approximation, about 2.23, I believe. The midpoint between these two is going to be the average of negative 5 and negative 3 over 2, and the average of 1 and 2. So that's negative 8 halves, which is negative 4. And that's 3 halves, or 1.5, if you prefer decimals. Just to verify those, I probably won't do this for the others, but for this one I'm going to sketch these points. I have negative 5, 1, and negative 3, 2. So here we have a segment. If you look here, it's longer than 2 because 2 is this distance here. It's got to be bigger than 2, so square root of 5 is just a little bigger than 2. And then halfway between the two is negative 4, positive 1.5, which is exactly what we found. Distance and midpoint formulas. Let's do another set. Negative 2 to 3 and 4 to negative 2. The distance between these 2 points we'll find by doing the square root of 4 minus negative 2 squared plus the negative 2 minus 3 squared. 6 squared is 36. Negative 5 squared is 25. So this is the square root of 61. I think 61 is prime. 3, 4, 6. Yeah. So I'm just going to leave it as the square root of 61. The midpoint I can find by doing negative 2 plus 4 over 2 and 3 plus negative 2 over 2. That's 2 over 2 is 1, and positive 1 over 2 is 1/2. 1/1/2. So that's the straightforward version. Sometimes you will get these questions backwards. An equation. Oh, not in your homework. Find the distance between the points. X or Y. Oh, there's a section right at the end. Although it's not in the examples in your book, so I will use this one. We're going to say we have the point negative 3, negative 1, and the point 2, y. And we know the distance between these points is the square root of 41. And our job is to find the value of y. So square root of 41 is the distance. That has to equal the square root of the difference between the x's squared plus the difference between the y's squared. So I'll square both sides and get 41 equals 5 squared is 25. Y plus 1 squared is y squared plus 2y plus 1. Don't forget to FOIL, don't just square those. I'm going to subtract the 41. Let's see, this makes 26 over here. Minus 41 is negative. Wait, that's 5. 2 from 3 is 1. Negative 15. Y squared plus 2y minus 15. So that leaves y plus 5, y minus 3. So y is either negative 5 or positive 3. Oh, I went off the bottom of my picture camera. Okay. So they're using it kind of backwards. The other section you'll have in your homework, you're supposed to classify a triangle. So the definitions for triangles you may not remember. The 3 types of triangles by their sides are scalene, which means none of the sides are the same. Isosceles, which means a pair of sides are the same, but the third side is different. And then equilateral means all 3 sides are the same length. So to figure out whether a given triangle, say a triangle given by its vertices specifically, 0, negative 3, 0, 3, and 3, 0. To figure out whether this triangle is scalene, isosceles, or equilateral, we need to find its distances. Let me go ahead and graph it, although you do not need to graph it to solve this problem. But I will give you the visual to help with your brains. 0, negative 3 is down here. 0, 3 is up here. And 3, 0 is right there. For the purposes of just determining whether the triangle is scalene, isosceles, or equilateral, I can clearly see this length here is longer than these lengths, and this is symmetric. So these lengths are going to be the same. This is an isosceles triangle. To verify that, I use the distance formula. So I find the distance between 0, negative 3, and 0, 3. 0 minus 0 squared plus 3 minus negative 3 squared is 6 squared 36 and 0. So the square root of 36 is 6. The distance between these 2 points would be the square root of, I'll call this one the second one, 3 minus 0 squared plus 0 minus 3 squared. 3 squared is 9, negative 3 squared is also 9, so this is the square root of 18, which is 3 square roots of 2. Not the same as the 6 that we found before. Here I'm going to get the square root of 3 minus 0 for the x's again, but for the y's I will get 0 minus negative 3. 3 squared 9, 3 squared 9, this is 3 square roots of 2 again. So it's the same as this one. This is isosceles. If all 3 sides are different, it's scaling. If all 3 sides are the same, it's equilateral. Write an equation for a perpendicular bisector. So we need to be able to write the perpendicular bisector for a given line segment. Let's do that, and that'll be our last example. So given 2 points, negative 2, 1, and 4, negative 7, we're going to find the perpendicular bisector. Now, perpendicular means it has to be at right angles, which is an indication of the slope. And then bisector means it has to be halfway in between, for which we'll need the midpoint. So I will do that first. Negative 2 plus 4, and 1 plus negative 7. So the midpoint is 2 divided by 2, which is 1, and negative 6 divided by 2, which is negative 3. The slope between these 2 points, oh, those are both m's. Sorry if that confuses you. Little m for slope, big M for midpoint here. The slope is y2 minus y1 over x2 minus x1. Minus negative 2 is plus 2. That's negative 8 over positive 6. So the slope of the segment is negative 4/3, which means if I need to be perpendicular to that, I need to change the sign and find the reciprocal. So the slope of my line is going to be positive 3/4. Turn it upside down, change the sign. And that's the information for my line. If you remember point slope form, it's y minus y1, which in this case is negative 3, so that becomes y plus 3, equals the slope m times x minus x1. If you want that in slope-intercept form, that'd be 3/4 x minus 3/4 minus 3. 3 is 12/4, so that makes a total of 15/4. If you don't like point slope form, you have to put it into y equals mx plus b, put the slope in, put 1, 3 in for x and y, solve for b to get your equation. But I think that's the long way around. I much prefer this. As I said, that was my last example. So you should be able to do these. Let me know if you get stuck.